Okay, this problem is specifically about scientific notation. If you don't know scientific notation, you couldn't have answered the problem. You might have been able to guess, and I'll go over that down here. But let's go over quickly some review of scientific notation. First of all, scientific notation is used to take really big numbers and put them in a format that is easier to look at, even though it might be a little confusing to you, or really small numbers and put those in a format that might be easier to look at. So we're going to talk about both creating and also unpacking. That's going across both sides of this equal sign, and we're talking about positive and negative. So the exponent and then the number. This is read 5.6 times 10 to the negative ninth. This is scientific notation format. You have a decimal point right there and one number to the left of the decimal point. The numbers that come after the decimal point, they can be numbers 1 through 9, or they can be zeros. That you don't have any control over. But true scientific notation means that your decimal point is right here, and then there's one number to the left. If you were given 56 times 10 to the negative 8, that would give you the same answer, but this is not scientific notation format. Scientific notation format always has the decimal point right there and then one number to the left. So now let's look at 5.6 times 10 to the negative 9. If the exponent is negative, that means it's going to be a small number, less than 1. So you're going to move it whichever way is going to make it smaller. So it depends on which side of this you're looking at. And by that I mean, since we're in the scientific notation format here, if you were to unpack this and look at it as a regular number, then you would add 8 zeros to the left of the 5 right there. And the reason it's 8 and not 9 is the first time you move the decimal point, you're moving it inside the number that you started with. So it's like this. You started with this number 5.6, but because it's raised to a negative power of 10, that means you're going to move the decimal point so that the number gets smaller. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8 places, 8 zeros, but it's 9 places because the first one moves it to there. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 total. So it would be 0.000000, 8 zeros, 5, 6. That's what scientific notation does to this number. 5.6 times 10 to the negative 9. You start with your 5, 6, move it 1, and then add 8 zeros, or move the decimal point 9 places total. Now if you're going the other direction in making it a larger number, it's the same principle, you're just going to the right now. So you have 4.9 to start with. You're going to move this decimal point 9 places to the right. But the first one takes in the 9 right here, so you're going to add 8 zeros. 8. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So that's 1, 2, 3, comma, 1, 2, 3. What is that? 4,900,000,000, something like that. That's how you create. If you were given this number right here, your decimal point started off there on the right, and you wanted to turn it into scientific notation, you would count back until you got to this place right there. So however many places you count back, that's how many times you raise the exponent to. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you end up with 4.9 times 10 to the ninth. All right, that's a quick review of scientific notation. I also wanted to show you that there's a little, I don't know if it's a trick, but something that you could be aware of that might help you with guessing. And this question happened to demonstrate it pretty well.